Okay, welcome back. So let's go ahead and talk about interpreting these higher order derivatives. Okay, so we know that from previous material that the first derivative describes the rate of change of our function, right? That's what the first derivative describes to us. So what does that mean for the second derivative, right? What does that describe? So the second derivative, I'll write it, the second derivative f double prime of x describes the rate of change of the first derivative. F prime of x. So our second derivative describes the rate of change of our rate of change in a sense. So here's a little summary table that helps us describe particularly these following examples, right? You can always refer to it for these type of examples where you're being asked, like, what is the first and second derivative describing? So if your first and second derivative are both positive, right? Then you are, I'll say, both positive, right? Then the function is increasing at an increasing rate. Okay. And likewise, if your function, your first derivative is negative and your second derivative is negative, right? Then you are decreasing at an increasing rate, right? So you're increasingly decreasing in a sense. I know the language is kind of strange, but you're increasingly decreasing. Okay, so what if you're opposite signs though? So what if your first derivative is positive and your second derivative is negative? Then since your first derivative is positive, you are increasing, but since your second derivative is negative, it's at a decreasing rate. Okay. And what if it's the opposite? Like your first derivative is negative and your second derivative is positive. Well, then you're decreasing, but you're still decreasing at a decreasing rate. Like it's your decrease is slowing down. Okay. So with that and keep in mind, let's go ahead and check out some application problems with these derivatives. So example 4, suppose the function C of t represents the amount of money in thousands of dollars a country spends on a local drug war t months from January 2000. Interpret the information provided by C prime of 15 equals 1.6. And this is a typo. This should be C double prime of 15 less than 0. Okay, so if we relate this to the table up here, right, we have our first derivative, C prime of 15 equals 16, right? So what that's saying is F prime 1.6 is positive, so it's greater than 0. So that's our first criteria. And if I look at the second derivative, it says that it's less than 0. So it's saying F double prime is less than 0. So it's going to fit this one right here, right? So that means we are increasing F is increasing at an at a decreasing rate. All right, so that's what it's saying is that we're increasing, but then it's decreasingly increasing where it's not increasing as much anymore. So let's kind of write out what the statement's saying though. So parts, let's look at the first derivative. C prime of 15 equals 1.6. What does this mean? So this tells us that the amount of money a country spends on the local drug war will increase by 1.6 thousand 15 months, right? That's what that 15 is telling us. 15 months from January 1st, 2000. Okay, so it's going to increase by 1.6 thousand 15 months after January 1st, 2000. So that's what the first derivative is telling us. So now let's check out what the second derivative is telling us. We don't actually have a numerical number, but we know that it's negative. Our second derivative is negative at 15. So that tells us that the amount of spending will decrease. That's what that negative is telling us in the following months after those 15 months. So it's going to decrease. And if you want to be specific, it's going to be less than 1.6 thousand. Right? It's going to be less than that amount. Okay, so that's how you would interpret this type of question. Okay, so let's go ahead and check out example 5. So law enforcement and drunk driving. Suppose that the function n of t represents the number of alcohol-related traffic accidents in a city t months after a strict new driving under the influence law has taken effect. So interpret the following information by the first derivative is negative 15 at 15, and the second derivative at 15 is negative, less than 0. So here we have a situation where our first derivative is negative and our second derivative is also negative. So what this means is that it's decreasing. And since it's both negative, it's decreasing at an increasing rate. Decreasing at an increasing rate. That means it's just going to keep more and more decreasing. So let's go ahead and put this into terms of this question. So, n prime of 15 equals negative 15. What does this tell us? This tells us that there will be 15 fewer alcohol related traffic accidents 15 months after the law has taken effect. Okay, so the negative 15 tells us there will be fewer less accidents and that 15 is our months after the law is taken into effect. So that's what our first derivative is telling us. So now what does the second one tell us, right? It's at 15 months, it's less than zero. We don't have a numerical value, but we know it's less than zero. So what does this tell us? This tells us that this amount will increase. And if you want to be specific, more than 15 in the following months. Okay. So we're decreasing it at an increasing rate. So that means at these 15 months, 15 fewer alcohol accidents are going to occur. And even more so after that, more, we're going to have a bigger decrease in alcohol related incidents. So you might have 20 less alcohol incidents, 30 less alcohol incidents. So we're decreasing at an increasing rate. So it's going to be more and more less accidents. Okay, so I know the wording is a little strange, but kind of think about it like that. Since this law, there's going to be more and more less accidents. Okay, so that is example 5. So last one, example 6. Suppose the function Wx represents the amount of money in thousands of dollars a country spends on welfare each month. Okay. So where X is the number of people in thousands applying for and receiving welfare. Interpret the information provided by W prime of 16 equals -8 and W prime of 16 equals, or I'm sorry, is less than 0. So we kind of have a similar situation here. We have F prime less than 0 and F double prime less than 0. All right, those are both negative values. So once again, we are decreasing at an increasing rate. Okay, so why don't you try this out and see what you come up with, and we will go over it, okay? Okay, welcome back. So here is a written out statement of this problem. Hopefully you got it at least sort of correct, but once again, you're taking it piece by piece and seeing if you can discuss how it's decreasing at an increasing rate. So what this first derivative is telling us that W prime of 16 -8 tells us that the amount of money a country spends on welfare each month will decrease by 8,000 because it's -8 when 16,000 people are applying and receiving welfare. All right, so it's decreasing by 8,000. So the second derivative right here is telling us that, right, W double prime of 16 less than 0, meaning negative, tells us that the amount of spending, right, this 8,000 that they're going to decrease is going to be even bigger. So they're going to decrease that amount more than 8,000. So they're going to be spending let they're going to be spending maybe 10,000 less, maybe 20,000 less, maybe 30,000 less. So this number is going to increase. So the decrease is increasing, right? We're in decreasingly getting bigger. Right? So the more and more people apply and receive welfare. So in the future. Okay, so that's how you handle these problems, right? We're talking about higher order derivatives. This last part was just about first and second derivative. So interpretations, okay? It's always the hard part. But that's it for this section, and I'll see you next time. Thank you.